All right, so like Trig lecture 411 through 414, student will review some concepts from Algebra 2. This coming week we're going to be doing more testing of this, that, and the other thing. I'm going to take a couple of, or rather look at a couple of concepts that we need to have in our toolbox, our mathematical toolbox as we move through our education. I want to remind you guys about arc length. The formula is S equals R theta. Theta is the measure of a central angle that's measured in radians of a circle. The central angle of a circle is measured in radians. S is the length of the intercepted arc, and R is the length of the radius. And here's what we're talking about here. Here's a circle. The central angle has its vertex at the center. It intercepts an arc. It intercepts two arcs, actually, major arc and a minor arc. This one's set up to find the length of the minor arc, but we could just as easily find the length of the major arc using the same formula. Radius, theta is the measure of the central angle. It has to be in radians. If they give it to us in degrees, we convert it to radians. And here's what we'll be looking for, the length of the intercepted arc. So here we go. Let's take a look at what we're dealing with. Find the length of the indicated arc round to the nearest tenth. So let's see what we got here. I've got a circle, radius 4, central angle of 300 degrees. So we're looking for this major arc here. Not very good at tracing circles, but hey, that's not too bad actually. This is the arc we're looking for. If the angle had been inside here, the 60-degree angle had been here, we would be looking for that arc, but it's not. So we're going to find the length of this major arc using this formula, S equals R theta. Where theta is in radians, so I'm looking for S. R is given to me as 4 centimeters. Theta is given to me in degrees, so I'm going to change that to radians real quick. Both divided by 6 would be 5 pi over 3 radians. And we can plug that in to our formula. And now we just evaluate this with our calculator, round it to the nearest tenth, and I will check my key and see if I got it right. If I can find my calculator. I just had, oh, there it is. And I have my key too. Yay, I'm almost on the ball. That's unusual. So I've got 20 times pi divided by 3. 4 times 5 is 20 times pi. Clear, clear. 4 times 5 times pi. And we're going to divide that by 3 equals, and round it to the nearest tenth, 20.9 units, which would be centimeters in this case. 20.9 centimeters. If I haven't made a mistake, and I will check to see if I have. Let's take a look at what the answer key says. 20.9 centimeters, yay! So we found the length of the major arc. If the angle had been indicated in here, we would have found this arc. Onward, through the fog. We'll get rid of this scratch work. We're given a circle, central angle, radius 5 feet. This time, the angle is measured in radians, so I don't have to convert it. And again, I'm looking for the major arc. That's just a coincidence. You'll be looking for major arc or minor arc, depending on what they give you. Try to clean this up just a little. Probably a mistake. No, that doesn't look too bad. That's the arc I'm looking for. So here we go. S is equal to R theta. S is the length of the indicated intercepted arc. R is given to me as 5 feet. Theta is given to me as 3 pi over 2 radians. And we just plug that into our calculator and round it to the nearest tenth because that's what we were asked to do. So I've got 3 times 5 is 15 times pi, 15 pi, and I want to divide that by 2 equals, gives me 23.56. I'm going to round that to the nearest tenth, 23.6 approximately feet. That's the length of this indicated arc. If we were to cut that and straighten it out and measure it, it would be approximately 23.6 feet. And the key says 23.6, so yay, we're off and running. There will be a few of those on today's worksheet, and there will also be equations that involve the variable in the exponent. And we have a tool for that, it's called the logarithm. And so we've done this before, but we're reviewing. So what we want to do is isolate the term that has the variable in the exponent. I want to get this by itself, so I want to get rid of a multiplied -5 first, and then take the log of both sides. Here we go. To do this, I want to divide both sides by -5, and that will give me 20 to the -7k power is equal to -19 over 5. I might leave it as a fraction. Let's see what it comes out to be. That'll be positive 3.8, or you could leave it as an improper fraction if you want to. And now I'm going to take the log of both sides. And the reason I'm going to do that is because logarithms have a property that enables me to move this exponent from a position of an exponent to a position of a coefficient. And so our variable will no longer be in the exponent. I'll have -7k log 20 is equal to log 3.8. And once I have this, I just isolate k by dividing both sides by -7 and log 20 at the same time. So k will equal log 3.8 divided by -7 log 20. And you can put that in parentheses if you want to when you're using your calculator, or you can go log 3.8 divided by -7 divided by log 20. However you want to do it, make sure, or you can use the fraction button. Just make sure you divide by -7 log 20. And then round to whatever it says to round to. What are we asked to round to? The nearest 10,000th. That's the 4th decimal place. So here we go. Let's take a look and see what we're going to get. Log 3.8 divided by parentheses -7 log 20 close parentheses equals, I get 0.006. Is that right? It is right. How about that? And it will be negative. I was thinking that can't be right, but it is right. It's approximately equal to negative 0.0637, rounding to the 4th decimal place. Okay, so the value of k here would be negative 0. If I plug this in right here, raise 20 to that power, multiplied by -5, I'll be very, very close to 19. It would be interesting to do that, but I won't do it now. You can do it if you want to. And I want to check once more just to make sure I didn't goof it up. Negative 0.0637. Yay. So let's take a look at another one. I'm going to subtract 6 from both sides to isolate this. So 20 to the m-4 is equal to 89. I'm going to take the log of both sides, log 20 to the m-4 power is equal to log 89. The reason I'm doing that, taking the log of both sides, is I see that my variable is in the exponent, and we can get that out of the exponent by taking the log of both sides and then using the property, the power property of logarithms, which enables us to move the exponent from a position of an exponent to a position of a coefficient, so to speak. So here we go. That's what I'm going to do. I'm going to move this to here. rewrite it. That would be the quantity, n minus 4, I'm moving the whole thing. So I'm putting it in parentheses, this whole thing, times log 20 is equal to log 89. Power property. Now I want to get m by itself. There are a couple of ways we can do this. What I'm going to do first is scooch all this stuff to the left. Give us a little bit more room. Oh no. Sometimes I'm just, there we go. It figures. Probably not going to let me do that, but I'm moving this to the position of the coefficient. And where was I? I'm going to try to get this n by itself, so I'm going to divide both sides by the log of 20. I'll do that right now. That'll give me m minus 4. If I divide this by 20, log 20, it'll disappear on this side. It'll show up on this side as log 89 divided by log 20. I divided this whole side by log 20, and the log 20's canceled, leaving me with n minus 4. I don't need these parentheses. And I divided this side by log 20 just to stay in balance. And now, as I said, I don't need these parentheses after I divide both sides by log 20. I'll add 4 to both sides, and m will equal log 89 over log 20 plus 4. I'm adding 4 to both sides. And I'll put that in my calculator and then round to the 4th decimal place because that's what it asked us to do. And then check to see if I got it right. And I'll be happy if I did, and I'll be sad if I didn't. Let's see what we got. Log 89. Log 89 divided by log 20 equals, and I want to add 4 to that, equals, and round it to the 4th decimal place. Let's scroll back now a little bit. It'll be 5.4983. If I haven't made a mistake, that means I could take 5.4983, plug it in right here, do this arithmetic, raise 20 to that power, add 6 to that, and I'll get really, really, really close to 95. It won't be exact because this is an approximation. Okay? And now let's check to see if I got the right answer. I'm afraid to look. 5.4983, yay! So there we go. These are the types of problems we'll be doing today. There's our answer right there on that one. How messy can I get? Anyhow, we're talking about arc length and finding the value of exponents, variables that are in the exponent using logarithms. You can do this.